Welcome to today's Tech Talk on getting started with DecisionOps for decision models using Gurobi, evaluating Gurobi Pi model formulation and performance. My name is Haley. I'm part of the Next Move team here, and I'll be your MC for today. Today's presenters are Tiffany Bogich, Head of Product here at Next Move, and Ryan O'Neill, Next Move CTO and co-founder. They're going to be covering quite a bit over the next 28 minutes or so, beginning with a primer and orientation to get us started today. And then diving right into the good stuff, a demo and speed run, walking through a really cool model that they've built out. So we're going to leave some time for Q&A at the end. We encourage you to use the Q&A feature at the bottom of your screen there, or drop your questions into the chat off to the side. Just keep an eye on that hosts and panelists versus everyone toggle to make sure that your question or comment goes to the right place. So with that, I'm going to disappear into the Zoom background and reemerge at the end for Q&A. And I'm going to hand it off to Tiff and Ryan to take it away.
Awesome. Thanks so much, Haley, and welcome everyone. So today we're going to be diving into two technologies, Gurobi and NextMove. But before we dive into how do they work together, I'll talk a bit about each of them separately. So Gurobi, as many of you know, is a fast, scalable commercial optimization solver. There's many applications to different use cases, and it's used for solving complex problems. NextMove is a DecisionOps platform for building, testing, deploying, and operating decision models. The platform integrates with many different optimization solutions, including Gurobi. So what happens when we bring these two technologies together? So with NextMove and Gurobi, you can operationalize custom decision models faster. You can perform repeatable, scalable experiments and share your results. And you can also use NextMove as a test bench for your Gurobi model, or as both your production and testing infrastructure for your Gurobi model. So more on that later. But before we go into a demo, just for context, so NextMove sits between your business data and your operational UI. So on the data side, it's everything needed to build a concept of your state that you want to make decisions on. So where are all my drivers? What are the tasks that I need to assign my workers to? Things like that. And then on the right, you have all of your operational tooling. So this could be an in-house service, something like a workforce management solution, or even a Google Sheet in some cases. And then in the center is where NextMove helps accelerate that development. So at the very base layer, we provide the infrastructure and ops tooling. And then building up from there, we provide some different language interfaces and optimization solvers, as well as applications and templates to help you get started with different solvers and languages. And so you can access all these things through developer tooling or a console user interface. Ryan will show both of these today in his demo. And so today we'll specifically be focusing on that infra and ops layer to develop and deploy a Gurobi Pi model and collaborate on testing and tuning it. So Ryan, as I'm promising, we'll make this real with a demo, but this gives you a quick orientation to what we're going to focus on in the platform today. And so the way we'll do this is with our favorite demo company, the NextMove FarmShare company. So the NextMove FarmShare is a consumer delivery service for farm-based goods, and we're expanding into avocados. So we want to price and supply avocados in a way that maximizes profits while also considering the cost of waste. So I'm a data scientist on the team, and I want to enlist Ryan, the decision engineer, to help me figure out how best to formulate a Gurobi Pi model to solve this problem. And spoiler alert, testing will be a big part of that. So before we dive in, let's think through how would I go about doing this today? So traditionally, the process is pretty ad hoc. So I'd assemble some test data on my local machine, write some custom code, likely in a notebook, and then I'd set up and perform a bunch of comparisons and try to keep track of all the different versions in a sane way, which is no small problem. And then if I get somewhere with that, I'd have to translate all of my results into probably some slides and share that with my team, and then probably go back and do it all again as we iterate. So if we start from there and then look at an ideal world, I'd have my test sets ready to go, no assembly required. I could just deploy and test my model code remotely in the same environment that I'm ultimately going to be running it on. And tests would be repeatable by anyone else on the team. So they could go in and rerun things and check my work. And then results are easy to share and consistently formatted. So going back and doing iterations doesn't mean I have to redo all of my results as well. So This ideal world is what NextMove enables and what we'll dive into today with a Gurobi Pi example. So to get us started on formulating a model to figure out the price and supply of our new avocado business at the farm share, we'll be adapting this avocado price optimization example from Gurobi. So as the data scientist on the team, I am using Pandas and stats model to train a regression. And I did all that work and then I handed off the coefficients to Ryan. So Ryan, take it away. Let's look at the model.
All right. Thanks, Tiff. Let me just share my screen. And thank you for sending over those regression coefficients. So let's start by just sort of reviewing what we have in production today and the updates that we're about to make. Can you see my screen?
Yep, looks great.
Great. All right. So if you recall, this is what our input looks like. It has the list of regions that we're going to ship avocados and sell them in. It has the total amount of supply that we're expecting. Then it has a cost per wasted product, which is essentially what does it cost us to take the unsold avocados and compost them. Transportation costs to the different regions, minimum and maximum allocations per region, and where the magic is right here. So this is where I've put the update that you sent me. So these are the coefficients from that regression. So we have a per region coefficient. These map to the regions up at the top. And then we have intercept, price, year, so on and so forth. And what these allow us to do is to take that regression and put it directly into the math programming model that we're going to use in Gurobi.
Nice.
And so that relationship between demand and price is sort of automatically accounted for by the math program. All right, so if we look at our code, again, this is just review for us, but good to look at. What I've done here, credit where it's due, this is from Gurobi's blog post on avocado pricing. I have taken that code and next movified it so it lives sort of seamlessly in our infrastructure. So what that really means is I have this main function with some command arguments that get passed from NextMove into the model, such as how long am I willing to run for? Or what is the optimality gap that I'm willing to accept? So I added that one here. We'll see those on the instances in console in a bit. And then what it does is it reads input from standard input and writes output to standard output. And we'll see that on the input and output of the model runs in a minute. The solve method is pretty much what they have in their blog post, but we'll go through it quickly. It has a few different variables. The primary actual decisions that we're going to make are what is the price to set avocados at in each region? How much do I charge for an avocado? And how many millions of avocados do I ship there? So there's the two primary decisions that I'm going to make. From that, we actually derive expected demand, again, based on that regression that you've done. And so this is a function that computes that the relationship between price and demand. And from there, we calculate inside the model expected sales waste and the objective value. The objective value here is the essentially revenue, which is price times sales minus our different costs, which include cost of waste and cost of transportation. And we're just trying to maximize that. And our constraints are pretty simple. We have to do something with all of the avocados. We can't sell avocados that we haven't shipped to a region, and we can't sell avocados that nobody wants. And then anything that is unsold is waste. So it's a fairly simple model. It is a nonlinear model. But what I think is really interesting about it is it combines that regression analysis directly into this model for the decision making for that relationship between price and demand. All right, so let's go and push that into our production infrastructure. All right, I'm going to go into this version of the model that's currently in production. And I think what we should do is just push it up into cloud and make sure it works. So I'm just going to push that main method up. And you can see here, it's packaging it up, sending it to NextMove Cloud. And I now have an endpoint, which is dev instance, because I haven't done anything to label or tag this one yet. I just pushed it up and I can send requests to it. So let's send that input I showed into the model and just make sure it works before we switch production over. And so what I'm doing here is a NextMove app run. So this is a remote run to my avocado price optimizer app. And I'm sending it the input that I just showed, and I'm using this execution class. So this is an 8-core machine with 16 gigabytes of memory, and it can run for up to 2 hours. And I'm passing two options. One is a duration limit of 30 minutes, and the other is just an optimality gap of 1%. So that's the model will stop when it reaches that. Okay, let's go look at the app. And so here you can see this is my avocado price optimizer app in Nextmove. If I refresh this, I should see that I have a new published executable. All right, there it is. Great. So the push worked. Right here is all of the API reference for this app. So I can see that it shows me examples of how to make runs, of how to get results, of how to manage the queue, and so on and so forth. So all the apps have this wrapped around them, and I can use this to interact with it programmatically, which I believe you have, Tiff.
Yes, that's great.
All right, so if I go over to runs, I'm going to refresh this, and I can see that the one that I just started has already succeeded. And I can look at this, I can see all the statistics that are coming out of it. These are not things that are provided by default with any model. These are things that I've added to the output. And what I can see here is that Nextmove is picking them up for me. We'll get into what some of these things are, but I can see things like, run duration and objective value is 46.7, that kind of stuff. And the rest of these were custom things that I added to the output. All right, so if I look at the input, it's basically what I showed already. And then if I look at the result, this is my structure that I chose, and it's what we have in production. What it gives me is a solution where it's the order of the regions, the price per avocado in each region, and the quantity to ship to each region. And then it gives me an expected value of this solution. So that's my revenue minus costs of, I believe that's 46.7 million. So pretty good.
Yeah, I think this is a great start, but we can't stop here. So this is just based on a point estimate, right? So if we're going to use this, it's really not going to align with what's happening in the real world. So we probably need to account for some more of that realism. Do you have an idea of how to do that?
Yeah, I mean, that's kind of where things get a little weird, right? I did take the liberty last time we brainstormed about this a little bit of adding the errors from that regression model you had into the input. So those are already there in this residuals block.
Nice.
And so what you can see here is I have a little bit of code that actually samples from that after running the optimization. And it will compute both in-sample and out-of-sample expectations around all the decision variables. And then it will subtract the out-of-sample from the in-sample. And so if I look at the objective value for each of these things, what this means here is that we're probably being overly optimistic in our sales projections to the tune of roughly $3.2 million. So yeah, that's not great.
Yeah.
So I have a prototype that I've been playing with, and we can go through that, which might help us account for this. The basic idea is what we do is we sample from those residuals that I was showing, and we add those into the model, because this is, I believe, what we call a case of simple recourse, where if we don't sell an avocado, we just compost it, and that has a fixed cost.
Yep.
So what we could do is we could sample from these residuals and add some of that variance into the optimization model, and that might give us a more realistic estimate. The thing is that as we do that, the size of the model grows. So I don't really have a great sense of how many scenarios or how much we should sample from this and actually stick it in the model, but we could try it.
Yeah, let's give it a try.
Okay, so let's go to this other version of the model that I've been prototyping. It's pretty much the same. The big differences are we're adding a scenarios argument, which is basically how many per region, how many samples do I take from those errors and inject into the model. So it's defaulting to 10, but we can test it with 10, 25, 100, 1,000, whatever we feel like.
Got it.
The other big difference here is our price and quantity variables are exactly the same. So these are essentially our first stage decisions. We're going to set a price and quantity per region, but we're going to shuffle and add errors to the demand. So demand is now going to be indexed by region and scenario. And the same is true of sales, waste, and value. And so the objective value for this model is not going to be just based on that 1 point estimate. It's going to take these first stage decisions and then compute expectations for lots of different scenarios based on them. So it's a simple way of incorporating some of that variance. But again, the downside here is that the more scenarios we add, the bigger the model is, the harder it gets to solve. Right now, our solve times are like under a second.
Got it, which is great.
Okay. All right, well, let's just try it and see if it works. So I'll go over to the stochastic version of the model, and let me push it up. All right, pushing succeeded, and let's do another run. And what I'm going to do here is pass the same input. The only difference here is this scenarios setting. So I've added another option to this model, and it's going to be, this one is scenarios 10.
Nice. And that was the new argument you added to the model, right?
Yep, exactly. And so if I go to runs over here, I refresh this. Okay, currently that's queued, but I should be able to see that in the instances that I've set up for this particular version. All right. So what I have now are a bunch of instances that I've configured in this infrastructure. And so we have a production instance, which is the deterministic model that we're running today. So if I click on that, I can see it's got these settings, duration of 30 minutes, 0.1% gap, optimality gap, so on and so forth. And it's configured to a particular version that I've uploaded to the model. So that's what we have today. And if I look at these other instances, what I've essentially done is associate all of these with the stochastic version of the model. And if I click on one of these, they just vary the scenarios.
Got it.
Everything else is the same. And you can see here they're pointing to the stochastic version of the model that I've tagged. So what I can do now is go back to here. I'll clear this so it's a little bit cleaner. And I will start a batch experiment so we can sort of answer this question of what's the trade-off between time and scenarios and closing that expectations gap, essentially. So if I run this command, what it's going to do is, first I'm going to change this number so that I get something new. It's going to run every input in this input set. So I've got a number where I've shuffled these errors. And it's going to run it with all of the stochastic instances that I've created, the ones that I just showed on that page. So it'll be 10 scenarios, 25, all the way through 250. And we'll be able to collect all those metrics that I showed in Cloud for all of these. So let me just kick this off. And it's going to tell me this requires 80 runs in Cloud. And it's fine by me. So here it goes. I've got an experiment ID. So we should be able to get some of these results pretty quickly.
Nice.
All right, let's go over to experiments and refresh this. All right, and I can see that it has already started. So I've got a bunch of runs here that are queued here. And those are going to start converting over to running pretty quickly. I will now do my Julia Child thing where I put this souffle into the oven and take a different one out because I just happened to run this right before our tech talk. And so let's go back to here. And what I can see here is the same experiment. I ran it with all of the stochastic instances with the number of scenarios set. And I've got all these different values, some of which are custom, some of which are provided by default that come out of the optimization. So the ones that we're interested in are really two things. One is this thing I'm calling in minus out demand. And so this is basically a measure of what does the model say it expects versus if I then do out of sampling and recompute the value, what is the gap between those? And if the model is overly optimistic, what it's going to be, this will be a positive value, and it will describe how overly optimistic it is in its projections. Of course, based on residuals from the fitted model, data science model. Okay, so let's sort these, and what you can see, actually, I probably want to look at a different one. Sorry. There we go. This one. Oh, that was demand. That's why I was messed up. Okay.
Yep.
Value is what I want. Okay. What you can see here is if I sort these by descending geometric mean, If I only add 10 scenarios, then that gap goes down to roughly about $320,000. Add about 25 scenarios, we're at 270,000. It looks like at around somewhere between 50 and 100 scenarios is pretty good. It starts to get close. So that's where we sort of narrow expectations such that they're in line with a potential reality.
Yep.
Maybe let's look then at how long these different models take to run. All right, so here's the run duration. Let me look, yeah, run duration. And so this is how long the model is actually running for inside the infrastructure once it's started. And it's pretty much exactly like I would expect. The more samples that I add, the longer it takes. Tiff, how long did you say you had to run for in the infrastructure that you set up?
Well, so I'm hooking it up to a Shiny app, and I need results in under a minute, ideally. This way, the operators can use it effectively. So, I think we should look for one of the scenarios that keeps us under that minute mark. Maybe
Okay.
50 looks good.
Yeah, I think that seems reasonable. So yeah, with 50, the geometric mean of the runtime was 31 point something
Yep.
seconds, and all of the instances that we have ran in under a minute. So that seems reasonable,
Right.
and that also had a pretty good difference between in sample and out of sample on the value. Okay.
Yep. Yeah, I think that's good.
All right. So then the next question that we want to answer is like if we move production from the current deterministic model to this new one where we're sampling,
Yep.
what does that do? All right, so I also created an acceptance test where we would compare these two. And so what I've done here is taken baseline model, which is the current production model, and a
Yep.
candidate model, which is this particular configuration with the 50 scenarios. And I've run it again on that same input set. But what I've defined is a bunch of metrics that I want to see move in different directions. And this is really just based on my sort of expectations, thinking about what will happen.
Yep.
So I'm saying here, I expect the run duration to go up. That seems reasonable. And I'm expecting the expected objective value to decrease because I
Yep.
believe that the deterministic model is overly optimistic. And so I want that gap in the model to go down. And so the question here is like, how much better are we getting at projecting the future in our optimization? So if we look at those two, we're going to see the run time is increasing as expected, but it's all
Yep.
under a minute, so that should be okay. We're okay with that.
Mhm.
And it is statistically significant because it says so here, so it must be true.
Perfect.
And if we look at the objective value, the gap in objective value between in sample and out of sample, we are also seeing that decrease significantly from roughly 3.25 million to 70,000-ish. So it's a pretty significant
That's great.
change.
Nice. Yeah, that looks good. I think we should ship it.
Okay, yeah, if you want to move forward, let's just update the instance then, the production instance, so it points over to the new model. So I'll go into here and we'll edit this. And first thing I have to do is just point it to our stochastic instance. And the next thing I need to do, remember we have that new parameter or option that has to be set, and I think it was 50, right?
Yep, that's 50.
Okay. All right, I'll click save, and there we are. We're in production. All right,
Nice,
thanks,
that's
Tiff.
great. So those same endpoints we can now use are going to point to that stochastic model. So that's
Correct.
perfect.
Yep. Everything forward. We should be good to go.
Great, awesome. Thanks, Ryan. All right. So we just went through a ton of stuff. So let's do a quick recap on what just happened. So our main conclusion here was we found that for this particular model, adding more scenarios made our results closer to reality. So we weren't overestimating our sales by so much, or at least closer to reality, where reality is out of sample results. So the trade-off being that it also increased our solve time. So we had to make a business decision as to what was acceptable, and then we could easily update the model based on that. These problems can get really large and complex quickly, and that's where Gurobi comes in. So Ryan showed how to deploy and run a custom Gurobi Pi model on NextMove. He iterated quickly on model formulation. We tried a few different things, and we're able to leverage 2 different types of experiments to compare our results with these different formulations. So they were batch and acceptance tests here. They were part of our historical testing suite. And this helped us figure out the best formulation for our avocado problem. And in the end, you saw how we could quickly update the model and make those updates live in production using instances. So there's some other features of the platform that we didn't cover today that we do incorporate into our farm share business model. These include our real-time production tests, such as shadow and switchback testing, and things like a CI/CD workflow and integrating with things like GitHub Actions. So that's something that we've touched on in previous Tech Talks. So I definitely encourage you to check those out for more or reach out if that's something you're looking to do that we didn't cover today. And so finally, in summary, we saw that tuning model formulation can yield significant business value, in this case, avocado sales estimates. And iterating on and testing different model formulations doesn't have to be awkward. In fact, it can be pretty streamlined and fast with NextMove. And with NextMove DecisionOps tooling, you can get to a repeatable, scalable path for optimizing different model formulations. So with that, I'm going to hand it back over to Haley if we have some time for Q&A.
And we do. As promised, I have returned with questions.
Great.
Thank you for walking through that, Tiff and Ryan. The first one that I saw come in on the side, and I think this is probably best for you, Ryan, but Tiff, feel free to chime in, is how do I hook up other machine learning models to this workflow, this platform?
Yeah, so there's a few things to consider, and it really depends on a bunch of factors. Depends on how much time you have, the capabilities of the solver, and how you want to implement those things, and also how you've done the machine learning part of it. So one of the things that was really nice about what we did today, and in Gurobi's example with the avocado pricing, is since the regression analysis is just a mathematical function, you can just directly add it to the model. So that's pretty cool. You could also extend this, and Gurobi, for example, has a least absolute deviation regression model. So you could compute that and sort of do a model pipeline and do the whole thing in Gurobi if you wanted. And you could experiment with some of that kind of stuff. In terms of sort of representing the variance of the real world in the model, what we've done here is sort of it's what's called the deterministic equivalent. That won't always work well. And so you can do other things like there's the L-shaped method, you can do simulation, you can sample inside of the search. It just kind of depends. But the cool thing with all of these approaches is you're able to take the machine learning libraries, whether those be in scikit-learn stats models or just coefficients like Tiff has given me, and incorporate them together in sort of the same runtime and ecosystem.
Excellent. Another question that came in is actually around demo code, Ryan. Will the demo code be something that you can share with folks?
Yes, yeah, that's no problem at all. We'll post that and send it out with materials.
All right, excellent. There's another one that's come in that I will read off here. Have you tried using piecewise linear constraints to model the demand curve by inputting price and demand points?
I have not. That would be an interesting thing to try.
Excellent. Perhaps the next Tech Talk. All right, I've got another one here, and maybe Tiff, I know you touched on this one earlier, so maybe you can expand a bit. But somebody has shared that I already have production infrastructure where I'm running my model. Can I use the NextMove setup that got demoed here today as kind of like a test bench on the side?
Yeah, no, definitely. So we have observability features, so you can pipe your production data back into NextMove and then use NextMove as your test bench for observability and testing. So that helps you kind of keep track of all your input in NextMove in a way that makes it really easy to gather for testing purposes.
Excellent. And then we've got a heavy one coming in from Carolyn around how do you see data science and ML, or data science and ML and optimization coming together in this space? Brief answers only.
Who's that one for?
You want to take a stab, Brian?
Yeah, I think the short answer is that they will become more deeply integrated over time, right? So that and that's actually been what like George B. Danzig was kind of predicting, I think, in the 60s. It's just that it's hard to do, right? And so as solvers have gotten better and better and faster, these things are becoming more and more possible. So it's one of the more exciting aspects where we sort of merge stochastic and deterministic optimization just into what is optimization, and it's still a bit nascent, but it's really where I think a lot of the promise lies.
And I think we're seeing a lot of different combinations. So decision science models feeding into optimization models feeding into decision science models,
Yeah.
or even those decision science models living inside of the optimization model. So it's pretty exciting to see these.
I think that's a good note to end on because we are just 1 minute over. So Tiff, if you flip to the next slide, there's a couple of links and call outs for folks, but we will certainly be emailing everyone who attended or did not get a chance to attend today, the recording and some relevant links to get rolling. So if anybody would like to go and try out the workflow that Ryan showed today, you could simply create a free Next Move account and you can get started there. There's pathways to start uploading custom code and all that good stuff. You can also chat with our team. Visit www.nextmv.io, and there's a way to get in touch with us and chat with us directly. And then we have a whole host of docs, blogs, and videos to dive into, also available on the website. So, Ryan, Tiff, thanks so much for the whirlwind tour of optimizing model formulation here today. We'll see everybody next time.
Thanks, Ellie.
Great. Thank you.